having a few dramas here, but looks like we're up and going. Yeah, thanks very much, Andy, and thanks everyone for having me. It's yeah, it's an exciting opportunity to talk to you, yeah, about some of the work we've been doing in the GFE and with forecast processing in Australia. And yeah, it's been a long journey in terms of the connections with the US, with the GFE and with myself personally. So I first came across to see what was happening in the US with GFE back in 2006, where back then I was a forecaster in the Darwin office, as Andy was saying, and I joined a project which was looking to adopt the software in Australia to use it for our forecast production. So you can see on the screen here a report I did after a first visit I did out to Boulder GSD to meet the developers there. And since then I've been across a few times. In 2017, that's when I met Andy, and Dan Baumgart there in La Crosse, Wisconsin, because it had been pointed out to me that there was some interesting work going on sort of in the area of streamlining the forecast process, which was an area of interest to us at the time. And then most recently I was out early this year for the AMS conference and visited a few other locations, including WPC, which is the photo down the bottom. So yeah, so I guess I've got some both understanding of what we're doing in Australia, but also some insights into sort of how that compares with the US. So that'll be the theme of the talk today. Next slide, please, Andy. Yeah, that's just my dog yawning, which is how I expected I was going to feel at the moment. Yeah, so what we'll touch on today, first a bit of context about more broadly what's going on in the Bureau of Meteorology in Australia in terms of how we're organising the provision of our public services and how we're, yeah, some of the reorganisations going on there. So that'll provide a bit of context for some of the drivers for things going on in the GFE and in what we're doing in forecasting land in Australia at the moment. I'll talk about some work we've done on using the GFE as a national system in Australia, which fits into that. And then some of the streamlining related activities which have been going on for quite some time now around guidance, GFE tools, and operating procedures for the forecasters, and also I'll briefly touch on how verification factors into that. In a little bit of a different topic, maybe Andy mentioned that there's a bit of interest at the moment, in particular interest in probabilistic services in Central Region. So I'll talk a bit about what we've done for our precipitation forecasting service in that regard in the GFE, and maybe just mention a couple of sort of bumps along the way we're having with that. Next slide. So just to set the scene a little bit in terms of some similarities and differences between our two nations and the sort of the meteorological context. So the continent of Australia is actually the same size as the contiguous US in area. Apologies too, most of my units here are going to be metric, so I hope that's okay with everyone. That's just yeah, how we think down here. Politically, we're somewhat similar in terms of how government is organised, in that we're also a federation of states with a federal government in a capital city, which is sitting in its own little non-state territory. So yeah, so there's some similarities too, just in the way that the various levels of government work in Australia compared to the US. Next slide. Looking at where we're situated in the world, we are somewhat closer to the equator than the US. So more of Australia getting into the tropics and even the deep tropics, such as up in Darwin, where I started my career as a forecaster. Topography, we're a lot flatter. So we've got about a third as high. Our highest peak is as you have in Alaska. We've got about 1/10 of the population, so we're very much around the coastal fringe, largely, with being quite a very dry interior and not much there in terms of infrastructure or people. We've got fewer meteorologists in the Bureau of Meteorology. Obviously, with a smaller population, we are also a smaller agency. Another significant difference, I think, in terms of is the relationship between the public and the private Met spheres. So I found a list where there were sort of 37 different organisations providing private Met services in Australia, but they're all very small and niche compared to the Bureau of Meteorology, which is the main player in the meteorological service space in Australia, which is very different to the US, of course, where there's a much more diverse and active and significant private sector. Observations, compared sort of the number of surface observations going into your RTMA gridded analysis compared with our comparison, we know as MSAS, and so we've got 700 compared to 14,000. So partly that is just like less infrastructure and fewer observations going along with that, but also I think we've taken a bit more of a restricted approach to how we've used observations and that sort of thing. We're very much leaning on the high quality obs which we take ourselves and being rather than going for quantity over quality. So there's a bit of a difference too about levels of information coming in. So next slide. So with some of those differences in the setup in Australia, the sorts of weather phenomena which are the big impacts are a bit different. So the table's showing like a insurance loss view in terms of impactfulness of some particular weather events, and just to point out that they tend to be tropical cyclones, summer flooding events, hailstorms in terms of deep convection, and of course bushfires, like the very significant bushfire season we had last year and into last summer. But if you look at killers, in terms of weather phenomena, heat wave is by far the biggest in terms of loss of life. Tornado, winter weather are much smaller impacts than is the case in the US. Next slide. A couple of years ago, the process started to set up a program of work which became known as the Public Services Transformation in the Bureau of Meteorology in Australia. It's quite similar to Evolve, take place in the National Weather Service, and maybe aspects of Weather Ready Nation. A big part of it is around changing the focus of operational meteorologists, moving off the production line of having a principal focus on pumping out or building forecast products, or building the forecast itself, and much more about interacting with users of forecasts to ensure the best decision making is made based on the available information about the future state of the atmosphere and its potential impacts. So, so this picture here was again from those bushfire seasons. So this is Dan Andrews with his arms folded. He's the Premier of Victoria, so it's like a governor of a state in the US, talking to one of our meteorologists, being briefed about the fire situation last summer. So I think he thought that was going to be the biggest thing in his career until COVID-19 came along, which he's grappling with every day now. Yeah, so next slide. Thank you. So in terms of the sorts of changes envisaged, this sort of schematic is laying out what the status quo has been in Australia in terms of how the general public weather forecast services, 7-day coastal waters, public weather forecast, and also the fire weather services are produced, where there have been 7 regional forecast centres, as they're known, and each one has a GFE domain covering an area of responsibility, which is by and large the state or territory in which the centre resides. And so then there's been the forecast process of the information coming in, the forecasters regionally coming up with their forecast in the GFE, and then issuing the products as much the same as what goes on in the US. Next slide, please. But under the public services transformation, in terms of what the target state in terms of forecast production is planned to be, there'll be no public weather routine forecast production happening in any of the regional offices. There will be centralised forecast production in the Melbourne office. So Melbourne is where the head office is of the Bureau of Meteorology. Even though we're a federal agency, and the capital is Canberra for historical reasons, we're based in Melbourne, with a backup or with some capacity in the Brisbane office as the other operational centre. And there will still be operational meteorologists in all those other state capitals, but they'll be moving into other roles, particularly decision support roles, more broadly than is the case with the National Weather Service in the US, in that we don't have, given there's not the same sort of thriving private met sector which can meet all the various niche needs in the community for meteorological services. The Bureau is a bit more involved in more of a range of partners in sort of industry areas, as well as sort of the traditional emergency management. So meteorologists would be involved in a range of different industries in providing decision support. And then also environmental prediction roles, which are more about specialist prediction in areas such as severe weather, like for tropical cyclones, say. Perth will be a centre of excellence and forecast production just specific to tropical cyclone forecast policy. For instance, hydrology, marine, and a number of other areas will have specialist staff devoted to some niche prediction areas. So that's 2021, as you'll see there. So that's next year. So that's very soon. So there is quite a big transformation required to make that viable. Next slide, please. So one facet of that is being able to use the GFE as a national system. So similarly to where in the Weather Prediction Centre in the US, you have, I think they've got a 5-kilometre grid resolution GFE across the CONUS. So we've got like a 6 kilometre grid similarly across Australia. So this is under development. And this is an area my team has had some involvement in terms of ensuring that the various aspects of the forecast process and configuration, etc., make sense for a national system. And so that's work in progress. Next slide, please. And so the current mode of operation there is that the national system up the top in this diagram can produce a limited number of the forecast grids and can then send them through to the 7 regional domains. Those are a mix of 6 and 3 kilometre resolution. That's historically how we've been set up with the GFE in Australia. Then all the product generation dissemination is going out as usual through the regional systems, and then we're incrementally getting different aspects of the forecast process up and going for the national system. At the moment, we're focusing on the fire weather process, for instance, and so there'll be more and more capability of the national production team, which also physically is gradually being assembled in Melbourne to furnish the grids required for the forecast process. Next slide, please. So then there'll be an evolution where then the national system will have its own dissemination capability set up, as indicated in this slide, but for some time the 3K resolution regions will be needed for that higher detail forecast service. The next slide, please. But then the ultimate target state will be to get a 3K resolution national GFE running, which can then cover the totality of the service. There'll be various technical challenges to overcome just in terms of performance. I know WPC would like to be running a 2.5K resolution CONUS GFE at the moment, but that's something they've struggled to get going. So yeah, there'll be a fair bit of technical work to be done on that. So that's one tack in terms of an aspect of more efficient forecast production through being able to run one instance of the GFE rather than 7 in forecast production. Also to say, another aspect of this national work will to allow what was called spatial sublocking, so that you could get in and edit just part of the grid while someone else could edit another part of the grid. So for instance, in the transition time, forecasters in Darwin could, in theory, get into the national GFE, lock off a rectangle of the domain and just edit there, while someone else could be editing another part of the country, or you could have a high, some high impact weather going on, say for New South Wales with an East Coast low event or something, where some detailed editing could be done there, whereas things more routine and broad brush could be treated by someone else for the remainder of the domain. That's all still to be being built. That's not operational yet, that capability. Next slide. So another tack in terms of facilitating that broader aim of getting the meteorologist off the production line and more into the high value engagement and decision support sort of roles is just generally streamlining the forecast process, whether it's a regional one or a national one in the Australian GFE. So that's been like a longer process, which has its seeds even back in the start of the use of the GFE in Australia, where we're adopting the system from the United States, of course, and there had been some early use in the US, so we had some insights from visiting and talking to developers and forecasters there about how things were shaping up. Some early decisions were made in Australia about being more centralized in terms of configuration and tool sets and formatter sets and the way things were initialized, so that was all standardized for the essentially the same setup for each of the regional GFEs. So we, rather than having a lot of local customization, the pros and cons to that as a development model, I guess, in terms of consistency compared to getting engagement from the grassroots. But the other thing was an early effort in terms of developing a common starting point. So having a statistical consensus, which could then mean that all the officers could be starting from the same place again to end up more efficiently with a consistent result. So that was all in development back there. Then there was a process of rollout around our 7 state forecasting offices, which took a fair number of years. It's quite a big undertaking. So and I was involved from advising on forecast process throughout that, and in terms of building smart tools, etc. During that process, one of the officers was quite innovative in terms of standardizing their forecast processes. In New South Wales, so based in Sydney, so the management there were very keen for their forecasters to be able to focus on the really significant weather in the short term. Didn't want forecasters spending a lot of time on a day 7 forecast when, well, who knows exactly what's going to happen anyway. So let's just make that very, 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 very streamlined through just following a very standard process every day. So there was a push in terms of standard operating procedures to have that very codified for the day 5 to 7 forecast in New South Wales, and then that led to putting that standard process into a GFE procedure, or GFE application, which was named First Cut Forecast, in the sense of, well, having a first go at the forecast, which you might then do more to if needed. So that was the genesis of a like a GFE procedure to embody a streamlined process. It took quite a while for that to be adopted much anywhere beyond New South Wales. Different officers, despite all like a strong push for consistent approaches and the way things were set up, nonetheless, different officers did to some extent take their own paths, and there were still the sorts of issues with intersite coordination and border inconsistencies, etc., which had been found from the early days in the National Weather Service as well. So in my team, which is in the research section of the Bureau, we undertook a process where we developed some ways to do some more standardized verification of the forecast process. Initially, it was generally to allow us to have some ways to use evidence more objectively to improve GFE tools in a general sense. So have a way to say, okay, well, here's our new tool for doing some aspect of the wind process or something. Let's do a systematic comparison of, oh, how good would the forecast have been if we used that tool rather than the existing tool, and then have a way to have a bit more of a sort of scientific method around how we justified the tools we had and how we improved them. But that was particularly brought to bear on this first cut forecast procedure, and looking at ways that we could sort of systematically and supported by verification improve that, but also have an understanding of how good it was compared with the forecast that was being issued, and answer those sort of questions about, well, where is the forecaster adding value in, in what places in the forecast process, and then feed that also more broadly into organisational and office decisions about how the forecast process was best conducted. So that sense would have been picked up in this public services transformation I was talking about earlier as having a focus on continuing to improve the streamlined forecast process and to have national standard operating procedures which incorporated that, so that there was a sufficient amount of streamlining, again, to be unlocking the human potential in terms of, you know, forecasters being able to take on other roles which they wouldn't have otherwise had time for. So that's sort of continuing into something we're in the middle of, really, in terms of expanding and improving that first cut forecast as a baseline sort of standardized process. Next slide, please. So in terms of the inputs to that process, the key input is our model blends guidance, as it's called in the US. We talk about having a consensus forecast approach. We have this for a range of surface and upper weather elements, including the standard sort of elements of the forecast, and cloud cover, also precipitation, which I'll talk about later when I come to talking about probabilistic precipitation forecast process. But the basic idea, it's very similar to what the National Blend of Models does in the US, where there's in our case, at the moment, it's a poor man's ensemble of largely global deterministic NWP, lining up on a common grid using a gridded analysis, our MSAS analysis, to bias correct, then doing a performance weighted average and using the high resolution analysis to do some downscaling of temperature. So that's the basic idea, and the whole thing hinges on, I guess, the benefit of simple bias correction, and also of the cancellation of random errors, which you get when you get sufficiently uncorrelated forecasts and average them together. So that's where the power of the technique comes. Next slide, please. So just to put this in a bit of a longer context, the development of that gridded OCF, as I say, has been going since the mid-2000s. It's tailing off now, so it's really getting into its final releases, and the Bureau will be switching over to a different platform for statistical post-processing known as Improver, and this is going to be a collaboration with the UK Met Office. It's a fully probabilistic system, so everything would be supplying a PDF, a probability distribution function, for every element from which you could draw single valued forecasts or aspects of the probability distribution as needed. And so the idea is that, with the expectation that probabilistic guidance with based on ensembles is the way of the future, this will provide us with well calibrated probabilistic outputs which can support a range of services. So that's not operational yet, that's for the future, but just to give you a bit of an idea of that roadmap. Next slide. Moving along the chain in terms of that streamlined forecast process, so I've talked about that gridded OCF starting point, or GOCF is the acronym, or OCF, you'll see in some of these slides. So that then feeds into, in the box here is the schematic of the aspects of the first cut forecast procedure. Essentially, the foundation grids are taken from the consensus guidance, various other elements are derived, consistency checks for so that things, weather elements either physically consistent or else look sensible next to each other, performed various adjustments onto the GFE grid, and it also derives various marine grids which are needed for the Coastal Waters Wind Service, and also all the fire weather grids. That's a grassland and forest fire danger indices. There's also a moorland fire danger index and various upper level parameters. So essentially the forecaster can do that at the press of a button if they choose, and that also gets run as an automated baseline forecast, which gets put into a guidance, one of the guidance databases under the blue line in the GFE, and the forecaster can also have a tool which just loads it straight in from there, which is a bit quicker and facilitates temporal and spatial blending with existing grids. Next slide. So as Andy mentioned at the beginning, I've had a fair bit of engagement with him and with people involved in the forecast builder in the Central Region. So it's been interesting to compare notes, and I won't go into this in great detail other than to say, look, it's conceptually very similar, including that starting point with statistically post-process guidance. Big differences, there's much more focus on winter weather with the top-down grids, which is just not given Australia being less prone to significant winter weather. Doesn't receive nearly so much focus in first cut forecast. And we have the additional marine and fire weather in our process. I'm very interested in what Forecast Builder's done in terms of getting probabilistic information about different weather types and then bringing that into the weather grid. So we don't have such sophisticated input guidance to allow us to do that in most cases. So that would be something I'd like us to be able to take further, for us to have some better weather type process in our first cut forecast. Next slide, please. So that procedure is has been available, the first cut forecast for all Australian regions since it was developed in New South Wales. As I said, we have sort of a common set of tools shared in Australia, so they all had it. This is an interesting diagnostic of to get a sense of to what extent that standard process is being used for the forecast, and getting a bit of a time series on that. So on the horizontal axis, we've got time from 2015 through to 2020, and then on the vertical axis, sorry, I was playing around with this slide at the last minute. That's a bad thing to do. So it's not RPSS. What the vertical axis is a count, like for each forecast, it's looking to see for every place in the forecast, for every different precipitation grid, or the whole set of precipitation grids, which I'll mention later when I'll talk about the precipitation forecast process, is the forecast that was issued exactly the same as the gridded OCF guidance within a very slight tolerance, as that guidance appears in the GFE. And so back in 2015, averaging across the nation, basically it was all the same is down the bottom. So actually this is a measure of how often is it not all the same. So down the bottom, it's all the same. Up the top, it's entirely different, differs for every forecast. And it was different sort of 80–90% of the time, and often that would be situations where the forecast was probably no rain. So they're sort of trivially, sorry, the times when it was probably different even more than that, except that, for cases of no rain, they come out the same anyway. so that doesn't distinguish. But then if you look on in time, and there are 3 lines here. So the green one, for instance, is for the 7-day forecast, and you can see that that one then dives down in 2019, and so that for the day 7 forecast, then it's only differing at all on 20% of occasions through to now, thereabouts. Similar for lead day 4, but still reasonable difference at lead day 1. And what the primary thing which has happened here is that a new national standard operating procedure was adopted by the regions during that 2018 to 2019 period, and then that mandated the use of the first cut forecast unless there was reason to intervene in the forecast. Next slide, please. And in that standard operating procedure, they had a rubric-based approach for considering, you know, whether intervention was called for or not, very much around the value of the intervention. So if it's significant weather, particularly relating to sort of warning threshold, and if there was a situation such that there was a high certainty that they were going to be able to add value to the forecast, given the information they had, then that would get you up into the red area of this matrix, and then that would be an expectation on the forecaster to be managing the forecast more closely and adjusting as they saw fit. Then if it's marginal, that's the yellow. But then if those cases didn't hold, then the directive was, well, just let it go. You've got more important things to do than being worrying about if it's, you know, going to be 15 or 16 degrees Celsius for the temperature forecast for day 7. And alongside this, there was a logging process. So the forecaster could log where they had done an intervention and some aspects of the reasoning around that. Next slide, please. So that then furnishes some information where the forecaster sort of did a self-assessment of, okay, where did this intervention actually fall in terms of that thinking around the impact and the likelihood of bettering the forecast. And you can see that, you know, sometimes it's more in that marginal area or getting into the more significant situations on 19% of occasions on this particular data. Next slide, please. The logging also gave some breakdown on what sort of elements are intervening. So here we can see wind and the weather grid were getting most attention, and I won't go into in the interest of time, I won't go into it in detail, but that obviously helps focus development effort on terms of where we need to try and improve the guidance or the GFE tools and the streamlined process. Next slide, please. So I mentioned that verification was a big theme alongside our work on the first cut forecast, and I won't again won't have time to go into this in any great depth, but just to note that for instance, by having verification, we can both see that, well, it seems reasonable that if we do a more streamlined process, from what we see of the performance of the first cut forecasts, that we wouldn't expect, you know, a big degradation in forecast performance suddenly. And then, in fact, we can confirm that that's the case by tracking performance. So this is for the probabilistic precipitation forecasts. It's a ranked probability skill score, which is sort of an overall summary metric. Again, same sort of time series as on that previous graph. Again, so the green is the lead day 7 forecast, and we can see that during that 2019 to 2020 period, there's been that upwards is better by this metric, and so we can see that the the forecast quality hasn't notably deteriorated here with that uptake of the more standardized process. There's much more to the whole verification story and what sort of verification is appropriate and how we've approached that. But I'll, in the interest of time, not going into that today. Next slide, please. So from rainfall verification, that leads nicely into our talking a bit about our probabilistic rainfall services. So when we adopted the GFE, we didn't really have any, there was nothing quantitative about our rainfall service or precipitation more generally to the public, beyond maybe some numbers a forecaster might mention in his radio interview or her radio interview. So the GFE opens the potential for or need to become quantitative, and given the lead of the US in pop forecasts, it seemed natural that we would take a similar approach. And I think we also, to some extent, inspired by work in some individual US offices using the QPF sort of approaches. We took a similar approach in the Australian GFE, so that supports services such as we have today, where as you'll see here, there's on the left that there are 3 hourly chance of rain, 3 hourly periods during the next couple of days, displayed to the public, and then also daily rainfall, so 24-hour periods. The Australian forecasts are in 24-hour chunks rather than the 12-hour chunks used in the US. And we've had this thing of putting both chance of any rain and then also a couple of rainfall amount figures, which happen to correspond to the 50th and 25th percentile amounts. So in this case, this was a pretty wet day. Forecast 40 to 120 millimeters of rain, 90% chance at 5% chance of any rain. Yeah, I might talk a bit more at the end about some of the communication aspects of presenting the rainfall in that way. Just move on for now, maybe to the next slide, Andy. So we also, of course, with the GFE products, we have the ability to do maps too. So we also provide those map-based products of rainfall amounts, the 50th, 25th, and also a 10th percentile, so an extreme high one, as well as the probability of rain. Next slide. So talking about the process behind that, so Gridded OCF provides a precipitation guidance. Similarly to the National Blend of Models, it's a lot more complicated than the guidance for other parameters. We make some use of ensemble inputs, which is, so precipitation is the first one where we've done this. Yeah, but won't go into more detail about that at the moment. Next slide. And then the GFE forecast process, the idea is we have a suite of precipitation related grids. So they're 3 hourly and daily time intervals, daily aligned to a standard UTC aligned day, which is used in common across Australia. And there are probabilities of various thresholds. The amounts here are millimeters, and then also rainfall, daily rainfall amounts relating to the expected value. So that's the mean across all of the possible different outcomes, as well as percentiles. And so essentially these are different slices of the probability distribution. So the idea is that we've got a procedure in the GFE called Pop Factory, which under the hood has a functional representation of the precipitation probability distribution with a couple of degrees of freedom, and then the forecaster, by inputting a couple of different grids about rainfall probability and amount, that constrains the degrees of freedom of that probability distribution, and then given that you can derive all the other grids. So the forecaster doesn't have to edit 12 grids or something, they're just editing a couple and driving the rest of the process. Next slide. And yeah, this is just a little bit about the actual distribution which is used, which is the Weigel distribution. Yeah, but I won't go into that anymore. So next slide. Yeah, so now just to talk a little bit about yeah, some of the challenges we've faced here. So one is around just how do you label or explain things. So we've got these two numbers about rainfall amount, which here are presented as a range and labeled possible rainfall. But then it's, in one sense, it seems biased high because we've got the median and upper quartile, but so that seems asymmetric. On the other hand, we always need to remember that rainfall is very non-Gaussian in its probability distribution. So we tend to think very much about what's reasonable for things being sort of like normally distributed, but that rainfall is nothing at all like that. So for instance, the average rainfall amount's probably in between those two numbers in many cases. So if one's choosing a range, it's a bit unclear what actually the best thing to use is for the range or how to describe it. But then in terms of interactions of the Bureau with various community sectors, a fair bit of confusion has been met in those sectors about what does this all mean, where we've got this thing about probability and we've got the thing about range, and sort of how do the three numbers fit together? And I think some people get quite disturbed. It's almost like just doing a bit of pop psychology, like they sort of experience a cognitive dissonance about being given these three numbers and not being sure, is that like there's an 80% chance it's going to be between 4 and 12 millimeters, or how does chance of any rain compare with those numbers? So just can you step on, Andy? So it's almost like we're kind of in one forecast presenting them with two slices, like slices in two directions of the PDF. And I think, again, without having tested this with any users or anything, but what I think could be going on is that a problem is that people, without having quite a deeper understanding of how the PDF works and how these things tie in, giving people to things along those two dimensions is just really hard to reconcile, compared to if you just give them chance of any rain and chance of 10 mils of rain or something, two different probabilities, that's okay. Or if you give them two different percentiles to give a range, well, that's okay. But kind of giving the numbers from the two different dimensions, that suddenly really puts extra stress on people and is hard for them to reconcile. You step forward, please. So what then has eventuated with some sort of recent discussion in the organisation, is that senior management not being very happy with how the rainfall service is being understood in the community, and for which that's definitely a point I take. But the way forward has been seen as, well, we'll stop reporting that chance of any rain and just give the people the range for the upfront forecast. Of course, people can dig in and get more detail about different aspects of this in the web or the app. But yeah, so it's I personally feel like we seem to be stepping backwards rather than forward. I think what we need to do is not shy away from rainfall probabilities, but work out, find better ways to make use of this in ways which help the decision making of the general public, but don't hide information which could be useful to some people, even if it's not useful to others. But it's how do we convey that in a way that's not confusing for people? And I think that's going to require great creativity, both in part on the science side, but also getting some creative and inventive users and forecasters together to kind of work out, well, how can we best use the richness in this information to convey it in a helpful way. So I think like another learning is that in a sense what we set up, this is about a decade ago, it was kind of, well, we're not quite sure how to do this, let's just try something, see how it goes, and we'll make it better as we go. But then got very locked into a particular service, and so I think there's also something to be said for we're exploring uncharted territory, like trying to do more sophisticated things with probabilistic information, finding ways to be a bit more agile so that we can try out different things and evolve and iteratively end up with a good service, rather than sort of trying something in the first place and then just getting very locked into that and finding it very hard to evolve. So yeah, so anyway, that's just a few of my reflections on what's a very interesting and challenging topic. Next slide. Yeah, so just in summary, there are lots of, I think, strong commonalities in what Central Region is doing with streamlined forecast process and what we're doing in the Bureau, also more generally in terms of approach to statistical guidance. We've similarly got questions around, well, how do we do probabilistic services in the future? What's the role of the meteorologist in all of that? How do we optimize that role? Where is it? Where do we need to keep the forecaster in the process, and where is it better to have the forecaster doing other things? So yeah, so I hope we can continue that dialogue. And just to do a little advertisement arising out of the workshop Andy came out to last year, we got together and did a paper just talking about some of these compare and contrast how we've approached the streamlining. So that'll be coming out hopefully soon in an Australian journal, the Journal of Southern Hemisphere Earth System Science. So just a little advertisement for that at the end. So thank you very much, and yeah, happy to take any questions.